Okay, this is a function that is actually the same one that you had on your preliminary assessment. And in that, you were asked, what is the limit of this function as x approaches 0? What is the limit as x approaches 4? You were asked a series of questions about it. So let's take a look at what's going on here. So we have this clearly discontinuous function where we have a continuous branch here from negative whatever up to x is equal to 0. At x is equal to 0, it jumps to a value of 2, and then it follows this curve here down until it reaches a value of x is equal to 2, and then it jumps up here to this value at x is equal to greater than 2, and it continues upward, but there's a hole here at x is equal to 4. So we really have a branch here, a branch here, a branch from x equals 2 to x equals 4, and then a branch from x is greater than 4 to infinity. So let's take a look at, suppose that we set this so that our x value is equal to 0. Well, f of x, as we can tell by this point here, f of x is equal to 2. But let's take a look at the limits. So as points approach x is equal to 0, and we can see that we have this little red point approaching from the negative side, this little yellow point approaching from the positive side. And so what we can see as those points get closer and closer to an x value of 0, we can see that their values diverge. So the yellow point here, it has a value of 1.98, getting closer and closer to 2. And the red point here has a value of negative 0.15, getting closer and closer to a value of 0. What that means is that the left-hand limit of this function at x is equal to 0, the left-hand limit is 0, the right-hand limit is 2, and what that means is that there is no general limit at x is equal to 0 for this function. The reason? The left-hand value equal to 0 and the right-hand value equal to 2 differ from each other. And we can see that when we look at this discontinuity here. There's a jump from the value when x is equal to 0 up to the value when x is 0 or greater. Okay, so then we were also asked to look at what happens when x is approaching positive 4. So again, we have our 2 points, this little red point and this little yellow point, each approaching an x value of 4. The yellow point's approaching from the positive side, the red point from the negative side. And as those points get closer and closer to having x values equal to 4, we can see that their y values, or the value of the function, are also getting closer and closer to 4 because the y values are moving closer and closer to a y value of 4 as the x values approach 4. So what we would say here is that our left-hand limit as x approaches 4 and our right-hand limit as x approaches 4 are both equal to, in this case, 4, because that's what the y value is. Interestingly, the function is not actually defined at x is equal to 4, and we can see that from these question marks here. There's a hole in the function. Nonetheless, the limit of this function as x approaches 4 from the negative side and x approaches 4 from the positive side is equal to 4. So we say this function does have a limit at x is equal to 4, even though it's not defined at x is equal to 4. And that is different from what happened when x was equal to 0, where we had divergent left-hand and right-hand limits, because as x approached 0 from the negative side, we had a left-hand limit of 0, but as x approached 0 from the positive side, we had a limit of y is equal to 2. So since these two diverge, there is no limit for this f of x function at x is equal to 0.